So far, we have talked about what quadratic equations are and how do we find the factors of quadratic equations. But how do we solve for quadratics? How do we get the actual values of x in quadratic equations? That's what we're learning in lesson 7.3. And the very first step is to be able to solve for a quadratic equation, the quadratic equation must equal 0. So we have to set this quadratic equation equal to 0. Otherwise, we cannot solve it, or at least not with this method. So once the quadratic equation is equal to 0, we can proceed to find the factors of the quadratic. So we need to turn the x squared plus 5x plus 6 into x plus 2 times x plus 3. And remember, we learned how to factorize this. This is the same problem we factorized in lesson 7.2 part 1. We're just not including the factorization process because it will make the video very long. And after we get the factors, the process is very straightforward. We take the first parenthesis, which is x plus 2, and we set it independently equal to 0. Then we take the second parenthesis, which is x plus 3, and we also set it independently equal to 0. So we take the two parentheses and set each one of them independently equal to 0. This is called the zero product property. So after we apply the zero product property, well, let's clean the board a little bit, we'll need a space. All we have to do is solve these two equations individually. Let's start with the x plus 2 equals 0. We have to move the plus 2, we have to isolate the x, so we have to move the plus 2 to the other side of the equation. Remember, we learned this in lesson 3.1, part 1 of this same Algebra I course, and we gotta do the opposite. What's the opposite of plus 2? We do a minus 2 because that cancels, but the golden rule of algebra says whatever we do on one side, we also do it on the other, so we also do minus 2 on the other side. 0 minus 2 is equal to minus 2, so x equals minus 2. But quadratics gives us two solutions because we also have the equation of x plus 3 equals 0. So we also have to solve for the plus 3. We have to move the plus 3 to the other side because we're solving for x, we're isolating the x. So we need to do minus 3, so we can cancel the 3 next to the x, but we must also do minus 3 on the right side of the equation. Then we apply 0 minus 3, which gives us x equals minus 3. And these two are the solutions. Yes, quadratic equations most of the times will give us two solutions. We will explore more about the solutions of quadratic equations in further lessons. For this lesson, let's keep practicing and let's solve one more quadratic. X squared plus 2x minus 8 equals 0. The quadratic equation equals 0, so we can proceed to find the factors of the quadratic. This is the same problem we factorized in lesson 7.2. If you want to review the factorization process, just review lesson 7.2 part 2. And after we get the factors, we proceed to the zero product property. We take the first parenthesis, the x plus 4, and we set it independently equal to 0. Move on to the other parenthesis, x minus 2, and we set it independently equal to 0 as well. We clean this up, but remember, zero product property, this is called, and we proceed to solving each equation individually. Let's start with the x plus 4 equals 0. We need to move that positive 4 to the other side. One more time. We learned this in lesson 3.1. The 4 is a positive, so we make it a negative. That way we can cancel the 4's on the side of the x. But if we do minus 4 on the left, we also do minus 4 on the right. 0 minus 4 gives us that x equals negative 4. We move on to the other equation. We have x minus 2, so we need to move that minus 2. The opposite of a minus 2 is a plus 2. That way they cancel. But if we did plus 2 on the left side of the equation, we also have to do plus 2 on the right side of the equation. 0 plus 2 is simply 2, so x equals 2. And these are the solutions to these quadratic equations. X equals negative 4 and x equals 2. You can also check your answers by replacing the x's in the equation. If you replace negative 4 for x, you'll get 0. If you replace x for a 2 in the equation, you also get 0.